I'd like to welcome you to our meeting for today. I am Paul Turner. I was Paul Turner before. I will be Paul Turner later. I'm your host for this meeting. This is our final meeting for the 2023-2024 season of SMPTE presentations for our group. We'll be starting up presentations again, hopefully in September, and we'll take it forward from there. Have some housekeeping. That's what I'm doing right now, just so we can get through this part of the presentation. And I'll find out where we go. Okay. So I am your chair for the next month. The end of next month, I am no longer your chair. The lovely Bob Huddleston has graciously consented to be our chair once again. So we appreciate Bob for that. Thank you, sir. Stepping up. Over. Our secretary and treasurer is Mona, who couldn't be here tonight. She sent her apologies. She has graciously accepted the position for next year. I think we can all accept it. Without Mona, this chapter would be in a world of hurt. So again, we owe her a great debt of our gratitude. Our current managers are Bob until such time as we get to July 1st when he becomes the chair. Tim Walker from AJA, John Henkel from Netgear, Robert Erickson, and John Laurent, who I know for sure is unaffiliated at this point in time. We have a couple of new managers joining us next year. So we have Jed Dean is joining us as a manager, and Matt Latau from Barco. So what's new? Well, of course, there's a network of similar-minded engineers that you can get to directly through our contacts here. You get to know what's coming up next in the Motion Imaging Journal. I find that to be one of the biggest benefits of being part of SMPTE, to be honest. There's some fascinating stuff there, constantly learning. And it's, to my opinion, it's getting better as time goes on. Content's getting much better. We do have virtual courses. They can be led by somebody or self-study. Generally speaking, the self-studies are free. Occasionally, the ones that are instructor-led have a small price against it, but generally speaking, you're looking at some free courses here. Excellent courses on things like HDR, if you want to learn more about HDR. Some courses on AI, for what that actually means to whoever is actually reading those letters. You can participate in the standards process. If you missed a conference, you have access to all of to the vast majority of presentations directly from SMPTE. And of course, you've got the possibility now of doing monthly subscriptions. It used to be that it was a yearly thing, and headquarters listened pretty closely to members who said that this was a bit of a financial burden for them, particularly those people who were paying for their own membership. And so now there's a monthly ability for you to pay your dues. There's a multitude of levels that you can go to. I won't waste too much time with you here in terms of how much they are. Executive, that's the top level where you have access to basically everything that you possibly want. Professional, that's what the vast majority of members are sitting at. It's $180 a year. If you're retired, you can stay up to date with what's going on with SMPTE for a mere $89 a year. If you're very early in your career, we're trying to make sure that SMPTE as an organization is attractive to younger members, because let's face it, a lot of us are aging out here, and we want to make sure that we bring in younger members. And to facilitate that, we've produced a version of a tier of membership for those who are early in their careers, and that's just a mere $49 a year. If you're a student, which looking at the group, I'm going to guess none of us are actually active students, but if you were, but it's not now. You can get membership for $15 a year. And of course, if you just want to be a fan and look on for the periphery, that's actually free. Here are the monthly dues that we've brought in. And as you can see, the important thing here is for individuals who are in the top three tiers here, we've tried to make this as economical as we possibly can as a monthly subscription into the organization. Tonight's presenter will be Cassidy Phillips. He's the Director of Customer Solutions for Switch. That's how you pronounce that, just so you know, switch.io. Since the ratification of SMPTE 2110, Cassidy is specialized in media networking and routing systems, leveraging the standard for live events, sports, broadcast media, and distributed campuses. Before moving into system design, Cassidy worked in air effecting operation roles at KEZI or ZI, if you happen to be English, which was is an ABC affiliate, DirecTV in Los Angeles, and News Corp for Fox News and Fox Business for a combined total of 12 years. He's been integral in several successful COTS 2110 IP and hybrid IP router and networking projects. In case you're not aware of the term, COTS is common off-the-shelf hardware, in other words, not bespoke hardware, and is an industry expert on IP and hybrid IP workflows for video. Cassidy is also the Western Regional Manager for SMPTE.
Hi, my name is Cassidy Phillips. I'm the Director of Customer Solutions for Switch.io, and I'm here to talk about expanding workflows into the cloud and utilizing the cloud as a dynamic media hub. Standards conversion in the cloud, protocol conversion in the cloud, SMPTE 2110 in the cloud. What does this mean to you? What's possible today, and what could we do in the future? So I was a master control operator for 13 years, and I did start at a little affiliate that dealt with satellite uplinks, downlinks, 1-inch tape, beta tape, almost any odd format you could think of. And we were always at the mercy of both the media sender and the connective infrastructure. Our options for manipulating the media quality and formats were limited by the quality of the source and the power of our own rack-mounted equipment. The elasticity of cloud environments allows for total customization of each program path. So here's what we've been doing for decades. Send and receive via satellite. We have SDI on-prem, so we have a stadium, for example, with a sporting event, cameras, microphones, capturing the action, and sending it via satellite up to something in orbit, which is then bouncing it back down for studio production, where they might have storage, edit suites, technical directors, graphics, and a studio show. And satellite is also used to put this out to a content distribution network. Over time, this has evolved to include fiber and IP, and even the cloud. So sending and receiving via cloud in 2022 may have looked something like this, where you have an SDI network on-prem, and we're going into an encoder to make SRT. The SRT is then passed through the cloud. Maybe there's some wrist involved, but ultimately the production is still happening on the ground. And even if I know I have camera 1 at the stadium and mic 1 at the stadium, by the time it gets to the other side of the cloud, I have no idea what the naming convention of this stream was, because I have the audio and video information, or maybe some ancillary data, but I don't have the router names, because this is not the same IP network. These are not connected in such a way that one router control system has knowledge and visibility of everything. Zero visibility in the cloud. In 2023, we gained the ability to actually see this information and connect these networks as if they were the same network. So I might be using multicast for a 2110 system on-prem. As a solutions architect, I was involved in many 2110 implementations for premium production, and this is a pretty common use case. Now, if I want to move that multicast into the cloud, I can do so, and I could even do it with lossless UDP to maintain the video quality all the way through without any drop packets. Once I'm in the cloud, though, I may still have to reach other consumers and endpoints with different limitations on what their capabilities are. So I'm still using SRT, I'm still using wrist, and then most of my production was still happening on the ground. But if I'm using camera 1 here, mic 1 here, I know from the stadium to the studio that this is cam 1 if I connect my network in such a way that I have visibility. So even in 2023, one router control system could potentially see this as a shared network. In 2024, just as an example, we show that more manufacturers and software creators are allowing their applications to be moved into the cloud. They have virtualized solutions. Maybe they were even virtualized on-prem to begin with. But now, combining these virtualized applications with that expanded network that I talked about allows us to move the production switcher, the graphics, editing, storage, just about any aspect of production you can think of, short of the actual audio and video capture at a live event, can now be moved and hosted in the cloud. And if I have cam 1 at the stadium, mic 1 at the stadium, I know it's camera 1 when I send it to graphics and the production switcher, even when these things are in the cloud. And I can have one router control system, potentially even tied to a hard router panel on site that is controlling all of this orchestration for you. So what are the benefits of extending IP through the cloud? Well, I have the freedom to work with the people and the technology that I want, anytime, anywhere. I can seamlessly connect diverse end-to-end workflows through the cloud and back. So whether I'm multi-site, multi-cloud, this can all behave as one network if I want it to. I have visibility into the cloud network and the individual packet performance. Just like I've had in my IP networks on-prem for years, I can now see what's happening in the cloud, as if it was in my facility. And I have the power at my fingertips in any cloud connected to any of my resources. So it's not just about what I have at my building anymore. So let's talk about in-cloud real-time standards conversion. Maybe I have a truck creating video A as JPEG XS 720p 5994. Well, if I put that into the cloud and I have the right applications in the cloud to handle real-time conversions, every one of my consumers over on the right can have whatever flavor of that video they want as a live stream. So maybe there's a stadium that can handle the same format. There's another stadium that actually wants an upscale to UHD. There's a studio show with 1080p. There are international feeds that want 50 frames per second. Instead of having to take the live stream and run it through their own hardware conversions, they can actually request the formats they need for their own home system directly from the central point, in this case, the cloud. So let's look again at what we used to do. Locked format transmission via satellite. So that same truck is sending 720p 5994 as MPEG. That's what everyone else is receiving. So the other stadiums, the studios, the international feeds, they're all just taking that same 720p 5994 and converting it when they receive it. Now, if I'm that laptop over in the lower right, I'm probably going to have to do a file transfer of some kind to transcode that, because I probably don't have the hardware in my laptop to do a live conversion. So when I map the current architecture over that same paradigm, I can see, well, now I can just put that 720p 5994 into the cloud, and I can give every consumer exactly what they need, potentially even on demand. So the benefits of in-cloud real-time standards conversion. I can grow my processing resources for big jobs or shrink when the workloads are light. So maybe I need to deal with that UHD for a weekend or one event, but I usually deal with HD. I only need to use the resources for a couple days. I don't have to buy a bunch of rack-mounted FPGA conversion devices. I can just use the cloud. I can customize any detail of the media program feeds for each affiliate. We talked about the frame rates, the resolutions. I could also change the color spaces. All of the processing that you might think about in an on-prem processor could now be done in the cloud. So go from SDR to HDR. And if we go back and think about those graphics applications in the cloud, maybe I can even give people custom graphics or custom commercial insertion. I accelerate the spin up and wind down of special projects and part-time streams. So I'm not shipping equipment, I'm not rolling in a truck. I can just turn these things on or turn them off in the cloud. And I'm simplifying my operational complexity to reduce points of failure, troubleshooting, and training time. Again, these are the same applications that you've been using on-prem, so they should look and feel the same way in the cloud that they do at your facility. I could even tie them back to hard panels, just like I do with my equipment today, so that I'm controlling the processing or routing of cloud-hosted equipment from a physical panel on site. As long as we're talking about expanding resources with that cloud elasticity, let's talk a little bit about path diversity and redundancy. I'm a big proponent of standards. I'm a fan of SMPTE. And in addition to 2110, I'm very familiar with 2022-7. In an on-prem setup, we typically see a red and a blue, so we have dual path. In a cloud setup, especially if we're using it as a satellite replacement configuration, you might want to do more than an A and a B path, or a red and a blue. So we can actually expand up to 8 paths. What's really interesting about this is, in addition to the reliability that it provides to media and entertainment, I see this requested from other verticals like financial data, healthcare, or government applications. So I'm duplicating 8 copies of the same stream from the producer, and then on the consumer side, I'm able to deduplicate or cherry pick the best packets from every single one of these 8 paths. So if I take a hit somewhere, or if one path is better than the other, my consumer is just taking the packets as it receives them and assembling in sequence based on both the packet timing and PTP timestamps. Here again is my dynamic media hub in the cloud. So I have my stadium, my studio, my laptop. In this case, I'm just using multicast as much as possible. And because my endpoints are all in the cloud, there might still be a little bit of unicast, SRT, RIST, because I can get back and forth from those things based on their own requirements. But my on-prem facilities that use maybe 2110 can just connect directly into the cloud with multicast. I can use Precision Timing Protocol, SMPTE 2110, 2022-7, and yes, even NMOS will work in this situation. So I can use ISO 4 discovery and ISO 5 connection management to control the routing and orchestration of the signals here, which means I can optimize my links from ground to cloud. So I'm not sending every single camera from the stadium. I'm just sending the couple cameras that might be used by the production switcher or the graphics machine, or maybe there's another stream that's just being captured directly to storage. And that's it. I'm not sending everything in my router into the cloud. Expect more from your cloud network. Extend your network. Don't just migrate to the cloud. Extend your current workflows into and through the cloud, gaining elasticity without compromising quality. Geo-dispersed operations teams. Your production can be distributed wherever you need it to be. Path diversity and disaster recovery. Create the best product from any mix of your cloud or on-prem resources. Do more business. Easily spin off your original content into additional program paths using cloud resources to create bespoke channels for your audience. I think we're entering that era of hyper-personalization. And so the ability to just extend your resources for specific events rather than worrying about having racks and racks of FPGA-based equipment and CPU and GPU that you own 24/7, 365. In this way, special events that put a heavy demand on you, use the cloud, and then you can turn that back down and go back to your normal daily operations. Thank you, and welcome to the Galactic Data Plane. For more information, reach out to info@switch.io. Or, if you have a direct question for me, Cassidy.Phillips@switch.io.